So now let's move to the second table in the sensitivity report, which relates to the right-hand side value of the constraints, which really represent our resources or how many resources we have to complete our production system. Now, accordingly, every constraint would be represented by a row in this table. And let's for example, consider the labor hours constraint. The labor hours constraint is given a value which is called a shadow price, a value of 16.67. The right-hand side value is again restated, and an allowable increase and an allowable decrease again. So now, how do I define a shadow price? A shadow price is defined by the marginal improvement in the profit or in the objective function if I increase the right-hand side value of my constraint by 1 unit. So just to give this more meaning, if for example now I have 1567 labor hours, meaning I have an additional labor hour, say an employee worked one extra additional hour of overtime, I know that my profit, which was 66,100, now increases by the shadow price of 16.67. So this means that an additional hour of labor is worth $16.67. Now, it also means that if I lose 1 hour, right, so if this is 1565, right, for some reason I lost 1 hour of labor, my profit now will be 66,100 minus 16.67. So really, it kind of sets a price, right, or a value to your resources. I mean, let's say we apply it to the pumps constraint, right? If I have an additional pump, right, the shadow price is 200, which happens to be equal to the right-hand side. So if this is now 201, my profit will improve by $200. So a pump at optimality is worth $200. So if someone says, if you can buy a pump for $50, right, it's less than the shadow price, so you probably should buy this pump because it will improve on your profit. So again, we have allowable increase and decrease. So how do I interpret those? How do I relate them to the shadow price? So I can use the value of the shadow price as long as the change doesn't exceed the allowable increase or doesn't go below the allowable decrease, right? So I can use those values of shadow prices as long as I'm within the allowable increase and decrease. And again, when I conduct analysis on a change in the right-hand side, again, I'm assuming that all other values remain the same. Yeah. Let's look at a few questions that would relate to this. Let's say if the first question one says, if the labor hour increased by 1 unit, right, or let's say by 1 hour, what is the new profit without having to resolve the LP? So now this is 1567. Again, as I stated, your answer would be the new profit is 66,100 plus the shadow price of 16.67. But you have to note that this sensitivity report, right, if I change the right-hand side, I can probably get the new profit if I'm within the allowable increase and decrease, but my new optimal solution will change. It will no longer remain 122 and 78. Because graphically, if you think about it, the optimal solution was the intersection of those two constraints. So if I change the right-hand side value of either of the binding constraints, then I have to resolve the problem to get the new optimal solution. And you can see this graphically, since the optimal solution is the intersection of two constraints. If I change the right-hand side, meaning I move one of the binding constraints, graphically the optimal solution will change. Right? So you have to remember, right? You have to recall that if the right-hand side of a binding constraint changes, then the optimal solution will change, but at least the shadow price will tell me what the new profit will be, right? So really the value of the shadow price is, it is an indicator of how valuable, or it puts, let's say in this case, a dollar amount on the value of your resources at optimality. Yeah. maybe another question, question 2 states, if the labor hours decrease by 8 units, what is the new profit without resolving? Let's say by 8 units, meaning by 8 hours. This goes down by 8 hours. Let's say an employee who works an 8-hour day shift misses a certain day of work. This goes down by 8. And now to be able to use the shadow price, I have to check a decrease of 8 is within the allowable decrease, right? So now I can state that the new profit is going to be 66,100 minus the shadow price of 16.67 times 8, right? So now this is my new profit, but when I want to find the new optimal solution, x1 star and x2 star, I will have to resolve the problem because I'm changing the right-hand side of a binding constraint. Now, let's look at another question. If we have 10 additional pumps, what can you infer about the optimal solution without having to resolve the problem, the optimal solution and profit? So if I have 10 additional pumps, 10 exceeds the allowable increase. So really, I cannot tell what the new profit is, right? Just from this sensitivity report, I cannot tell what the new profit is, and obviously what the new x1 star and x2 star are. But I can at least infer that for this allowable increase of 7, right? At least my profit will improve by 7 times 200, right? Because I increased I have 10 additional pumps. The first 7 will I can use the shadow price at least apply it for the first 7, and I can say that that we have to resolve, but we can state that the profit increases by at least 7 times 200, which is 1,400. And the last point is that I want to make is that tubing, right? The tubing constraint, feet of tubing, is a non-binding constraint, and it has a shadow price of 0. So that should make sense because remember the slack was 168, right? Meaning I can lose up to 168 feet of tubing, right, without changing the optimal profit. If I give you more feet of tubing, right, if you have more feet of tubing, your solution will not improve, right? Obviously, because this is a non-binding constraint. So it should make sense that the shadow price of the non-binding constraint is 0, right? But recall that the slack of the binding was 0, right? But the shadow price of the binding constraints is positive. And the allowable increase is infinity because, right, physically, it doesn't matter how many extra feet of tubing I have, my optimal solution will not change.